Solve the triangle where b equals 25, c equals 30, and the angle b is 25 degrees. We always draw an arbitrary generic triangle. We don't assume that this is the right triangle. We then label A, B, C, not drawn to scale. The opposite to the angle B is the little b, the opposite to the angle A is the little a, and the opposite to the angle C is the little c. We're given that b equals 25, c equals 30, and the angle B is 25 degrees. Using the law of sines, we have sine of A, which is now unknown, over A, unknown as well, equals sine of B, but B is 25 degrees, over little b, which is 25, equals sine of C, which is unknown, over 30. There are one equation, two equations, and three equations here. If we use the first two ratios as an equation, then we would have two unknowns. That is not good. If we use the first and the last, then we would have three unknowns. But if we use the second and the last, then there is only one unknown. And so we will use the last two ratio, and then we isolate sine of C. We cannot isolate C right away, but to get to C, we will get sine C first. Cross multiply to get 30 times sine of 25 degrees over 25. This 25 and this 25, they do not cancel out. We then put this in a calculator and evaluate what this sine of C is. The calculator will give us 0.5071. It is a good idea to round it to 4 decimal places in the intermediate step. This is sine of C, and so to get C, we simply use arcsine or sine inverse of 0.5071, and this is approximately 30.47 degrees, and this is the measure of the angle C. Now, this is an acute angle, and we know that there are two angles between 0 and 180 that will give us the same sine of C. We found one already, 30.47 degrees. There is another angle whose sine is also 0.5071. This angle that we found is in the first quadrant because we use inverse trick. This is 30.47. If we want the second angle, which is still less than 180 degrees, any angle that is less than 180 degrees is potentially an angle in a triangle. To find out what this angle is, we simply take 180 minus 30.47, and so a second candidate is 149.53 degrees. We still need to figure out if this is possible, but as of now, there are two values of C such that sine of C is 0.5071, and the first C is 30.47. The second C is 149.53 degrees. Now that we found C, we will be able to find A. A is 180 degrees minus B, 25, minus C. If we use C 30.47 degrees, then A is 124.53 degrees. If we were to use another angle C, then A is 180 degrees minus 25 minus 149.53 degrees, and this will give us 5.48 degrees. And so this might still be possible. We then need to find A as well. We now update the law of sines. If we use A 124.53 degrees, then sine of A is sine of 124.53 degrees over A equals sine of 25 degrees over 25. And we will be able to find A this way. A is 25 times sine of 124.53 degrees over sine of 25 degrees. We then plug this into a calculator and get 48.73. This is the length of the side that is opposite to A. Now, if we were to use 5.48 for the angle A, then sine of A is now 5.48 degrees over A equals sine of 25 degrees over 25. We then isolate A and get A equal 25 times sine of 5.48 degrees over sine of 25 degrees. And so we now evaluate sine of 5.48 times 25 divided by sine of 25, which is 5.65. And so to summarize this, we found two triangles. The first triangle is the angle A is 124.53 degrees with the corresponding opposite side 48.73. The angle B has a measure of 25 degrees given with the opposite side 25. The angle C has a measure of 30.47 degrees and the opposite side 30. Before we moved on, we might want to check the ratio. The largest angle should have the largest corresponding side. The angle A is the largest out of these three angles, so the opposite side should be the largest. That checks out. The smallest angle should accompany the smallest or the shortest opposite side, which is 25. And so this looks reasonable. The second triangle has the measure of the angle A be 5.48 degrees with the opposite side 5.65. The angle B is given 25 degrees with the opposite side 25. And the angle C is 149.53 degrees with the opposite side given 30. And again, we still need to check to see if it is reasonable. The largest angle is the angle C with the largest or the longest opposite sides, so this checks out. The smallest angle is 5.48, the angle A, with the smallest or the shortest opposite sides, so this checks out as well. There are two possible triangles, two solutions in this case.